Connected.
Hello. Hello students. Today we are going to solve problems in matter waves. If the value of Planck constant is more than its present value, the de Broglie wavelength associated with a material particle will be. Dear student, de Broglie wavelength is h upon mv. If Planck constant is more, then definitely de Broglie wavelength will be more. It will be more. So out of 4 choice, the correct choice is option 1. Out of 4 choice, the correct choice is option 1. A moving car 2000 kg mass, velocity of 30 meter per second has associated the de Broglie wavelength given as. Dear student, de Broglie wavelength can be written as 6.62, that is value of Planck constant into 10 power minus 34 upon mv. Mass is given 2000 kg, velocity is given 30 meter per second. After solving this equation, we will get this is approximately 3.3. First you divide this. This is 6.62 into 10 power, this is 3, this is 4. 10 power 4 means 10 power minus 38 upon 6. So approximately 1 into 10 power minus 38 meter. Okay. Out of 4 choice, the correct answer is option 3. 1.1 into 10 power minus 38 meter. Out of 4 choice, the correct choice is option 1. Option 3. Option 3 is the correct answer. A particle of rest mass m0 moves with speed c. Here m effective will become equal to m rest upon under root 1 minus v square upon c square. Since v equal to c, so this will become infinity. So de Broglie wavelength h upon m effective into v. Since m effective has become infinity, okay, so de Broglie wavelength has become 0. So out of 4 choice, the correct choice is option 1. The velocity at which the mass of a particle becomes twice its rest mass. This is very good question for NEET JEE 26. Mass of the particle becomes twice its rest mass, means 2m equal to m divided by under root 1 minus v square upon c square. So 1 minus v square upon c square will give you 1 upon 2. Make the square. This will give us 1 upon 4. So v square upon c square equal to 3 upon 4. So dear student, we will get v equal to root 3 upon 2c. Out of 4 choice, the correct answer is option 3. Option 3 is the correct answer. The momentum of photon of energy 1 mega electron volt will be approximately momentum equal to E upon C. Energy is 1 mega electron volt means 10 power 6, 1.6 into 10 power minus 19 joule, and C is 3 into 10 power 8 meter per second. After solving this, we will get this is approximately 2. This is 10 power 6, so 10 power 2. 10 power 2 means 10 power minus 21, so this is 0.5 kilogram meter per second. So out of 4 choice, the correct choice is 5 into 10 power minus 22. kilogram meter per second. So we will mark option 2 as correct answer. We will mark option 2 as correct answer. The frequency of a photon of momentum p will be frequency of photon equal to E upon C, and what is E equal to what? Frequency of photon equal to E upon H, and E is what? P into C upon H. So out of 4 choice, the correct choice is option 1. Option 1 is the correct answer. The momentum of photon of wavelength 0.01 angstrom will be P equal to H upon lambda. H is 6.62 into 10 power minus 34. Lambda is 0.01 angstrom, means 10 power minus 12 meter, because 1 angstrom equal to 10 power minus 10 meter. So this is 6.62 into 10 power minus 22. Oh, directly 10 power 12 H. You can write directly 10 power 12 H. So out of 4 choice, the correct choice is option 3. Option 3 is the correct answer. The energy of photon in electron volt of wavelength 5000 angstrom will be. Energy of photon is written as AC upon lambda. What is AC? 12,400 electron volt angstrom. And what is lambda? 5000 angstrom. 5 into 10 power 3 angstrom. So angstrom will get cancelled. Now this will become this 0, 0, 0 means 10. 124 upon 50 means approximately 2.48 directly electron volt. So out of 4 choice, the correct choice is option 1. Option 1 is the correct answer. Out of 4 choice, the correct answer is option 1. The wavelength of a photon of momentum 6.6 into 10 power minus 24 kilogram meter per second will be lambda equal to H upon P. H is 6.62 into 10 power minus 34, and momentum is 6.6 into 10 power minus 24. So this is 1 meter. 1 meter equal to how much? 10 power 10 angstrom. 1 angstrom equal to 10 power minus 10 meter. So 1 meter equal to 10 power 10 angstrom. Oh ho ho. This is not 1 meter. This is 10 power minus 10 meter. So this is 1 angstrom. So out of 4 choice, the correct answer is option 2. Option 2 is the correct answer. The momentum of photon of frequency 10 power 9 hertz will be momentum equal to h mu upon c. So we can write 6.62 into 10 power minus 34 into 10 power 9 upon 3 into 10 power 8. After solving this equation, we will get this is 2.2, 10 power 8, 10 power 9 means 10. So this is 10 power minus 33. This is the answer. Kilogram meter per second. Out of 4 choice, the correct choice is option 3. The energy of an alpha particle whose de Broglie wavelength is 0.004 angstrom will be. Energy of alpha directly we can write 0.101 upon under root V. This is lambda, not energy, lambda. So under root V equal to 0.1 upon lambda means 0.004. So this will come 1 upon 10 into 4 upon 1000. So this is 400 under root. This is not 400 under root. This is 400. So V is what? 1600 this volt. So energy of alpha will be equal to twice 320000 electron volt. This is what? 4060. But answer is not matching. Okay. Let's recalculate again. Energy of alpha particles with de Broglie wavelength is even 0.04 angstrom. Okay. Lambda equal to h upon under root 2 me. So under root 2 me equal to h upon lambda. So 2 me equal to h square upon lambda square. So E equal to h square upon 2m lambda square. Now see what is h? 6.62 into 10 power minus 34 into 6.62 into 10 power minus 34. What is 2? Mass of alpha is 4 times mass of proton. 1.66 into 10 power minus 27. And what is lambda? This is 4 into 10 power minus 3 minus 13. So 16 into 10 power minus 26. Now we can solve it very easily. This is 1.6, so this will get cancelled by 4 approximately. This is 4, this will get cancelled with 1.5. This is 4 will get cancelled by 4. This is 4 into 2, 8. So 1.5 upon 8. This is 10 power minus 68. And this is 10 power plus 27 plus 26. Okay, this is the solution. Now we can see 1.5 upon 8 into 6, 7, 13, 2, 4, 5, 53. 8 में 3 जाएगा. This is 10 power 5 and 1 minus 15 electron volt. So 8 upon 1.5 upon 8 means approximately 0.2. So we can write 2 into 10 power minus 16. This we can write 2 into 10 power minus 7 giga 10 power 12. Giga means 10 power 12. Only one option is matching. Okay, so we can tick only one option. No other option is there. So we will tick option 4. No other option is matching. The energies of an photon and electron of mass m are same. The ratio of de Broglie wavelength. The energy of photon, lambda photon equal to hc upon e. Lambda electron equal to h upon under root 2me. Energy is given same. So ratio of de Broglie wavelength. This is the ratio. So hc upon e into under root 2me upon h. So hh will get cancelled. So this will be c under root 2m upon e. Out of 4 choice, the correct choice is option 3. Out of 4 choice, the correct choice is option 3. Two particles of mass m1 and m2 respectively are identically charged and accelerated by same potential if de Broglie wavelength associated with them are lambda 1 and lambda 2, then the de Broglie wavelength of a charged particle is h upon under root 2m qv. This means charge is same and potential difference is also same. So lambda 1 upon lambda 2 will be equal to under root m2 upon m1. This is the solution. Out of 4 choice, the correct choice is option 2. Option 2 is the correct answer. If E1, E2 and E3 are respectively kinetic energy of electron, alpha particle and proton, each having the same de Broglie wavelength. Dear student, if de Broglie wavelength is same, this is very good question for NEET and JEE 26. If de Broglie wavelength is same, then their momentum is also same. And what is momentum? Momentum is under root 2me. So if mass is more, energy will be less. Maximum mass is there for the alpha particle, its energy will be least. Mass is least for electron, its energy will be maximum. So energy of electron E1 greater than E2 greater than E3, E1, E1, E3, E1 greater than E3 greater than E2. Okay. So out of 4 choice, energy of electron is more than energy of proton is more than energy of alpha. So out of 4 choice, the correct choice is option 1. The de Broglie wavelength of a particle of mass m and charge E accelerated through a potential V will be. This is direct formula, lambda equal to h upon under root 2 m eV. Out of 4 choice, the correct choice is option 1. This is again very good question for NEET JEE 26. If the momentum of electron is changed by Pm, then the de Broglie wavelength associated with it changes by 0.5%. The initial momentum of electron will be. Dear student, lambda equal to h upon p. So this is relation delta lambda upon lambda equal to minus delta p upon p. Okay. De Broglie wavelength is changing by 0.5%. This is 5 upon 1000. This is 1 upon 200. So delta p will be equal to p upon 200. So initial momentum will be 200 delta p and delta p is given pm. So out of 4 choice, the correct choice is option 3 is the correct answer. The thermal energy of a particle at temperature T degree Kelvin is kT. Then the associated de Broglie wavelength will be. Dear student, the formula for de Broglie wavelength equal to h upon under root 2 me and energy is given kT. So the formula will become under root 2m kT. So out of 4 choice, the correct choice is option 2. Option 2 is the correct answer. The average thermal energy of neutrons, each of mass m and temperature T Kelvin is 3 by 2 kT. Then the de Broglie wavelength of neutron corresponds to this. because average thermal energy is 3 by 2 kT. H lambda equal to H upon under root 2 ME. Substitute this value of energy. We will get H upon under root 3 M kT. So out of 4 choice, the correct answer is option 1. Option 1 is the correct answer. What potential must be applied to an electron microscope so that it may produce an electron of wavelength 1 angstrom? The general formula for lambda in angstrom equal to 150.5 in volt. This is the formula. So 1 angstrom means under root V. This is not this. Formula is lambda equal to 12.27 upon under root V angstrom. So under root V will be equal to 12.27 volt. So V will be equal to 150.5 volt. So energy will be equal to 150.5 electron volt, because when one electron is accelerated with a potential difference of 1 volt, energy is 1 electron volt. So out of 4 choice, the correct choice is option 3. Option 3 is the correct answer. In Davison-Germer experiment, this is very good question for NEET JEE 26. An electron beam of 60 electron energy fall normally to the surface of crystal and maximum intensity is obtained at angle 60 degree to the direction of incident beam. The interatomic distance in the lattice plane of the crystal. This is being asked. This distance is asked. Interatomic. So d sine theta, taking 1 order diffraction, and lambda 12.27 upon under root V. 60 electron volt means 60 volt. So after solving this, we will get 12.27 upon under root 60. Sine 60 means root 3 upon 2. This is the solution. This is, dear student, this is approximately 25. This is approximately 180. 180 means approximately 13. So 2, something 2. So answer is 1.8 angstrom. The lambda remains in angstrom, so D will also come in angstrom. Okay. So out of 4 choice, the correct choice is option 3. So for this question, the correct choice is option 3. And this question is very important, very most expected for NEET JEE 26. Okay. So follow this.